First and foremost, I want to thank everybody for being here. This is by far the biggest turnout I've seen and helping us track down Franklin's Bumblebee. Franklin's Bumblebee was last seen just up the road where we're going to head in a couple of minutes in 2006. And the more boots on the ground, the more people we have looking for this particular critter, the better the chances are.
Even though it hasn't been observed recently, I'm optimistic that it's still out there. We just haven't found it.
If I see a bee with a black abdomen, I'm going to suspect it's Franklin's.
It's as black as they get, really. We got to show this one to Link, too.
Hey, Link.
Link.
Oh, cool.
Come here.
Uh-oh.
We got another good one here.
Tyler did it again.
The bumblebee, known by its scientific name, bombus. There are over 250 species harvesting nectar and pollen from flowering plants across the globe. Bumblebees populate the flowers that produce some of our richest crops, such as blueberries, raspberries, cucumbers, and tomatoes.
I like bumblebees because they're charismatic and lovable. I even love their name. I mean, think about it. The people who gave them the name Bumblebee, they were onto something. Because when you watch them, they're big, they're buzzy, they're fuzzy. They're not especially elegant. They're kind of bumbling along as they go from flower to flower. But it's part of that awkward, clunky, large behavior of their flight on flower after flower after flower that makes them good pollinators, because they are so buzzy and big that they're good at transferring pollen from flower to flower.
Over the past 30 years, there has been a steep decline in the number of bumblebees observed in the wild. This recent decline is concerning due to the important role it plays to our agriculture and flowering plants that occupy our landscape.
Around a quarter of the bumblebees in North America are facing some degree of extinction risk, and the indication that we have there is that they're just not found in the areas where they used to be.
Many of the bumblebee species are struggling to keep their place in the world.
In the past 20 years alone, 25% of North America's bumblebee species are considered endangered. This same trend is being observed all around the world by research scientists and conservationists.
Here's a bumblebee. Yeah, going too fast. It's gone.
Professor David Klein has been studying the bumblebee for several decades and is one of the world's most knowledgeable experts on the bumblebee.
This is the bee hotel. So most of the solitary bee species nest in the soil, and many of them like these vertical walls. They're such a cool study group to work with because on one hand they're incredibly important for people functionally because they pollinate all wild plants, they pollinate our crops. And on the other hand they are threatened in their existence. In the Netherlands about 56% of the species are on the national red list, indicating that they are threatened in their existence. Of all the bumblebee species, you have a couple that do really well and are still amongst the most common wild pollinators that you can find out there. And then you have this big other group that struggle, that go extinct, that decline severely. Of course, then the researcher in me becomes really interested. I want to know why.
Currently in the United States, there's two bumblebees that are protected under the Endangered Species Act. There's the rusty-patched bumblebee, which lives in the upper Midwest and the Northeast. Most recently, Franklin's bumblebee has been added to the endangered species list. Getting a species listed actually takes a long time, and get this, the average time it takes is 12 years. Frankly, it's an unacceptably long time. Species are supposed to be listed after 1 year. There have been 47 species that have gone extinct while waiting to be put on the protection list.
Something like the rusty-patched bumblebee, which once upon a time lived roughly from North Dakota to Maine, south to Georgia, like roughly think about that as a triangle. That was its historic range. And it's now disappeared from, probably 90 to 97% of its range. It's just not found in any of the areas where it once was. And that's how we know that some species are in decline.
Several bumblebee species are being observed by the scientific community as slowly disappearing, or like one particular species, Franklin's bumblebee, is possibly extinct.
Good morning, everybody. My name is Jeff Everett. I'm a biologist with the Fish and Wildlife Service. I'm the lead biologist for Franklin's bumblebee. The species expert, Robin Thorpe, who passed away unfortunately a couple of years ago, believed that the best way to find Franklin's bumblebee was to intensively survey the last known location at what is historically the peak of colony activity, when in theory the colonies are at their largest, the most number of workers are out on the landscape, and our detectability is highest. Franklin's was relatively easy to find back when it was abundant on the landscape in the 80s and into the 90s, and then about the early 2000s, the species started to decline, and for reasons that are pretty poorly understood. There are several hypotheses about what exactly happened to Franklin's, and that it was a combination of introduced disease and a variety of other threats to the species that, acting synergistically, just kind of wiped them out over time. There's over about 250 species of bumblebees in the world, and depending on where you draw certain taxonomic lines, we have 46 or 48 here in North America. Franklin's bumblebee is unique compared to all the other bumblebees in that it is very, very narrowly endemic, which means it was only ever found in a very small area. 3 counties here in southern Oregon and 2 in northern California. Most bumblebees are very, very widespread across their native habitats. Franklin's was always very narrowly endemic, and it's something that we didn't understand. Why was it not more widespread? It wasn't limited by geography, because it's been found at mountain elevations like this at places higher than some of the passes to the south and to the east, and also to the north up into the Willamette Valley. So it could have spread, but it didn't. Also, it wasn't tied to a specific host plant like certain pollinator and plant interaction. It's been documented using a variety of floral species, many of which are found across the western United States. So it wasn't held here by geography. It wasn't held here because of some special habitat niche or foraging requirement or something like that. So we really don't know why Franklin's was always extremely limited on the landscape compared to all the other bumblebees that we have, most of which are really quite widespread. Even with a relatively narrowly distributed bumblebee, something that uses a variety of habitats, even though we're only talking about an area that's about 13,000 square miles, there's a lot of this habitat that is higher elevation, federally owned, and has never been systematically searched for bumblebees. So Franklin's could very well still be out there. It's just that we're not necessarily looking in the right places at the right times. This survey that we do this week is again carrying on Robin's tradition of looking at the last known location at the peak of colony activity when you'd think detectability would be at its greatest. I wanted to introduce Lincoln Best from the Oregon Bee Atlas, and I also wanted to point out Joe Engler, who is all camouflaged up over here. These 2 gentlemen are some of your taxonomic authorities. If we find something that looks like what we are after or something that you can't identify, these guys can help you out. So one of the things we would like not to do is further the spread of pathogens throughout our bee communities. And so we will be up the road here setting up a station where you can sanitize your nets if you haven't already done that. It's just a quick bleach soak and a rinse and then air dry, which won't take long today. And we also have alcohol wipes available to sanitize capture vials and those kinds of things. So we want to do what we can to limit the spread of pathogens amongst the bee communities. I haven't seen a rattlesnake up here, but it's not outside the realm of possibility. So just be mindful of where you're stepping. All right, I think we're in pretty good shape.
You don't have to do it all day. You can do it for an hour. It doesn't really matter. But when you're counting the bumblebees, you want to count every bumblebee you see. So we can look at the bumblebees of conservation concern. Of course, we have 2 museum specimens of Bombus franklini from the 1950s. We have a worker and a male. And so the tail has a very little bit of off-white on the very tip of the abdomen. And then on the top of the thorax, the yellow extends about 2/3 of the way back. And those are the diagnostic features that we're looking for today.
Great turnout. This is really pretty exciting to have this many people looking and this many people interested in what we're doing and why we're here. First time I did this, we had maybe 20 people join us, and we're close to 70. It gets a little bit bigger every year, and really like the diversity of it too. There's the federal biologists and conservation organizations, but there's also grassroots, local landowners, local conservation organizations, just citizen scientists, volunteers, a couple of students, and the state agencies are quite well represented this year as well. So it's really exciting to see the enthusiasm.
The way to identify Franklin's, he was saying the main thing to look for was a little bit of sparse whiteness on the tip of the tail, the last couple segments. They're kind of usually notched, like usually black in the middle.
But just the fact that the yellow comes further back than just the shoulders, but it's probably hard to recognize in a lot of cases. And so on Occidentalis and a lot of the other bumblebees here, it's just the anterior of the shoulders really, but on Franklin's, that yellow extends 2/3 back on the thorax. And so it's not easy to recognize really, but if you see something like that, then bring it back and we'll take a look and see what it is. Yeah, there's tons of, convergence in their mimicry in this region. So there's like 8 species that look almost all the same.
Yeah.
It's really challenging to tell bumblebees apart. They look really obvious. They have big, bright colors. They're a big bee, but you have to look really closely. Sometimes for some of them, they have perfectly black abdomens with a yellow stripe right across the tip in exactly the same place, and they're 2 different species. You actually have to look under a microscope and see how long their cheek is, the difference from their eye to their jaw. And on a bumblebee, that's really small. So telling the difference, it takes looking at hundreds and hundreds of bees, and then suddenly your brain is, it learns. It figures out how to see what you're seeing. If I see a bee with a black abdomen and virtually no color on the abdomen, I'm going to suspect it's Franklin's, and then I'm going to take it to Link. Link's the man. So we'll always confirm. So trust but verify, right? Yeah.
If you guys want to go hike, there's a bowl down there. It's super nice. Vegetation should be it's really nice. Yeah, tons of flowers, beautiful. And if you're adventurous, you can go down to the bottom of the bowl where there's different plant communities. Okay. Just be loud. Okay. There's bears. It's not good. Just make some noise and don't try and surprise them. That's bear. There's a big old black bear that lives down here. And so there's often a lot of black bear activity, especially down near the bottom. You can see where they've been rolling logs, foraging for ants. But you can see it's a big one. Yeah, full size.
Do you think the Franklin bumblebee is still out there?
I do, or I certainly think it can be. inhabited a really wild and diverse region of the country in which relatively few people live. And the areas that we've searched for it are really, for the most part, the most highly impacted areas where bees probably generally aren't doing that great. But there's a bunch of mountains in Northern California that are wilderness, that haven't been touched by agriculture, and there's really no reason we would expect a rapid population crash. I'm hopeful that someone will refine this bee.
Franklin's bumblebee is important because if we can figure out exactly what happened to it, why did we see that really steep decline in the bee, and what changed and how this critter interacted with its habitat, and learn from what happened, we can then apply meaningful conservation from the lessons that we learn towards other at-risk pollinator species, including a couple of bumblebees that we're concerned about. One of the other bumblebees we're interested in is western bumblebee, which we still have on the landscape, but has seen significant declines. And we do find them here most years, not every year, but most years.
Yeah, 2 years ago, I found the western bumblebee like right over the edge of this little ridge here. The western is very rare out here. As in the western side of Oregon and Washington, it's very few. I was the only one to find a western bumblebee here out of everybody like 2 years ago. And we didn't find the western bumblebee at all last year. But overall, its population is down something like 95% across its range, which really spans the whole western United States.
And then Suckley's cuckoo bumblebee is another bee that we've been petitioned to list under the Endangered Species Act, and that hasn't been seen in Oregon in the last 5 or 6 years.
Oh, here comes Mr. Bushman with something in his net. You got a bumblebee? Let's take a look. So everyone watch your footing. It's pretty steep. So male bees don't have stingers. And so I can tell this is a male bumblebee because it has really long antennae. It's got long, skinny hind legs, and it has an extra long and skinny abdomen. This is a male cuckoo, so the female cuckoos are really big. Their bodies are really thick and well armored, and like a cuckoo bird, they sneak into the nest of their host and lay an egg, and then the host's workers raise the cuckoo's egg for them. What do you got, Henry?
It's interesting.
This is the female cuckoo bumblebee. All of the females of this species would look like this. They'd all be large and all be capable of invading a nest.
These cuckoo bumblebees are rare and special, and they're also in decline, and which is why the center's petitioned for protections for Suckley's cuckoo and the variable cuckoo bumblebee.
If we catch a female Bombus flavitus, which is the other common cuckoo bumblebee up here, it has a big stinger, but it also has S6, the apical sternite, modified into a big curved spine, and presumably to open the abdominal segments of the queen it's battling to be able to sting it more effectively. So cuckoo bumblebees don't collect pollen. They don't really manage their own nest. It's just reproductive females and males. And so this is one of the males. And we can just let him go.
Okay.
When there's tons of forage around, you don't travel far. You want to forage really efficiently. And so, you know, up on Mount Ashland here, we have tons of great flowers. And so these bees shouldn't really need to, you know, travel kilometers on a foraging bout. They'll stick as close to home as they can. Are these huge things delphinium? Wow, these are all giant delphinium. And they're probably still a week away from blooming as well, but these things will go 6 feet high. Red flowers are usually not for bees. However, you know, bees, bumblebees, and solitary bees will visit the red paintbrush. And yesterday, you know, I was suspicious that any bees visited Columbine. Yesterday, we were up at Table Mountain, and we saw a little sweat bee crawl up the corolla of the Columbine. So You know, in some cases, yes.
The story of Franklin's bumblebee is really interesting.
It declined very quickly over a very short amount of time, and we don't know exactly how abundant the overall population, how healthy the populations were, until we started noticing that the species was becoming rarer and harder to find.
And this we see for many, many species, and this sort of confirms our belief that many of the bumblebee species are struggling to sort of, you know, keep their place in the world.
Even though it hasn't been observed recently, I'm optimistic that it's still out there. We just haven't found it. It's one of my favorite things to do, to be honest, is to go out and like hunt for this bee. I'm looking at thousands of bees every day, trying to look for this one bee that's like, look, that's just a little bit different from all the rest of them. That would just be so exciting if we found it. I feel like that's front page news.
So there's not a single issue that explains the decline of bumblebees. It's a complex of factors. Most important ones are habitat destruction and loss. So simply, you know, natural habitat has been converted into built-up areas or arable land. The second one is pests and diseases. The third one is loss of food, so the disappearance of flowers from the countryside. And then more recently, it's exposure to pesticides.
And the reasons for bumblebee decline are poorly understood and very complicated because it's not any one particular thing. If you take a colony of bumblebees and you load that colony with a number of diseases, bumblebees fall victim to a number of pretty nasty stuff. There's mites and parasites and fungus and all kinds of other things, all of which act to weaken the bee, make its job harder to do, make it sick, make it harder to forage and fly, all those things. And then you throw pesticide applications, broad spectrum insecticides and those kinds of things, which many of which are really bad news for our bees. You're beating up their immune systems, you're beating up their ability to interact with their landscape and grow and reproduce. And then you throw competition from managed bees on top of it, and a number of other factors, large-scale habitat alterations, and those kinds of things, and it's sort of a death by 1,000 cuts over time.
Many of these bees are threatened because they fail to reproduce successfully, and then the numbers dwindle and decline. They fail to reproduce because of lack of floral resources within a foraging range of their nests. Of course, you know, bees are fixed to their nests, so any food needs to be available within, say, 500 meters of their nests. Otherwise, it becomes too costly to collect it. An interesting fact that many people don't know is that bees are just about the only species group that rely on flowers for everything. So they need the nectar themselves to fuel them, and they need pollen and nectar to feed their offspring. It's the only thing they need, flowers. So it's increasingly difficult for bumblebees to find food. They have this colony that lives for 2 months, up to 6 months. And throughout that whole period, there needs to be food. If there's a gap of 2 weeks, for example, then the colony dies. And then they won't produce a single new queen. With other bee species, that's much simpler. They can reproduce immediately. But with bumblebees, they need this continuous period of time with floral resources. Bees are exceptionally important for the pollination of plants. And pollination of plants simply refers to the process where pollen from one flower is being transferred to another flower. And pollen is required to fertilize the other flower and thereby produce the seeds or the fruits with which the plants reproduce.
There's a number of statistics you can hear when you start looking at pollinator conservation, that you hear sound bites like, 3 out of every 4 bites of food that we take are in one way or another dependent upon bees, whether it's honeybees or bumblebees or other species of managed bees. And so pollination is fundamentally important to the human existence because it provides such an incredible ecosystem service in terms of food production for us.
So there is this statement going around that if the bees go extinct, then 4 years later people will go extinct. It's not as black and white as that, fortunately for us. But we will lose many, many wild plant species, and we will lose all kinds of animals that depend on these bees. Yes, we will suffer as well because we have a lot of the really nice foodstuffs, especially the fruits and the nuts and the oil crops that produce more when they are pollinated or produce products of a better quality. And that, of course, will become worse if we don't have bees anymore.
And it could be that some places will become less suitable for bees in general because there's not as many flowering species.
If the bees disappear, then the plants don't reproduce as well, and then they might decline as well. So sometimes individual bee species just forage on one single plant species. And then you can imagine that if you lose that species, then this particular plant species will suffer the consequences.
It looks like we're pretty good for floral resources here. This is corn lily, this is lupin.
You can always tell when something's foraging on the lupins because they have these neon orange-red pollen stashes.
And there's a variety of other things blooming here. This stuff over here that's got these little white flowers is a favorite of western bumblebee. That's bistort. That's a good place to look for target species. If you're looking for western bumblebees, that's one of the flowers you might pay pretty close attention to. Not only is this the last known location for Franklin's bumblebee, but as far as bumblebee habitat, this is about as good as it gets in this area. This is really high quality stuff. It's higher elevation and federally owned. There's a lot of naturally occurring wildflowers. There's not a lot of disturbance or anthropogenic impacts, development, those kinds of things. There's also very little, if any, pesticide use and other things that can really harm our bees. But in particular, at this elevation, this whole hillside here, there's some naturally occurring springs that are in here. And these steeper slopes that have this kind of geography, they tend to hold moisture very late in the growing season when a lot of this stuff dries out. And the lupin can be as tall as I am, and the bees will pile into those areas.
Oh, here's a different bumblebee, a mixtus.
You get a mixtus?
Yeah. And so as soon as we see this different kind of flower, we get a different kind of bumblebee. She has a pale tail, but you can see, compared to the bees we've seen so far, which primarily just have yellow shoulders and then some yellow markings near the end of the abdomen, this one has extensive yellow on the thorax. Although there's not hundreds of species of bumblebees, there's tons of variation in their color forms. And so that makes it actually really difficult to identify a lot of bumblebees because you have to become accustomed to seeing these subtle differences. You hear me today talking about, oh, this bumblebee has yellow shoulders. Well, like 8 bumblebee species up here have yellow shoulders. So just little differences that you can learn over time.
Link always laughs when the new OBA students say, oh, I'm going to start on bumblebees because they'll be easy. And to a person, it's like, oh man, bumblebees are so hard.
Oh, here, I think you can add this one to your list too. Look at how big this one is. I don't think I've seen one quite so yellow. It's a trophy eye. And it's also like a little bit bigger, so it feels like
Let's look.
Do you think it's a queen or a worker?
It's probably a worker, to be honest. But.
Oh, you think it's an evidence?
It's a positus.
Yellow further down.
Yeah, white-shouldered bumblebee.
Oh, yeah.
The shoulders aren't super white on this one, but Western Oregon sometimes has a novel color form with more yellowy orange shoulders.
What was your big tell on that?
So Nevadensis has black on T4 and T5. And this bee obviously has more yellow.
Yeah, it's yellow
apical on the
all
abdomen.
Of them, yeah, apical part of the segments. Yeah. Oh,
That's a big one. And
yeah, I've never seen it. I've seen a positive
this is a
before,
worker,
but never a big one.
This is actually an appositus worker. So the queens are another full size bigger.
Yeah.
They're
Holy
huge.
moly.
What makes bees a bit vulnerable is that they are tied to a nest. So they, in the nest they provide food to their offspring, usually eggs, and they have to find food within foraging range of that nest. And this is usually no more than 500 meters. So if there are no flowers within that distance from the nest entrance, then they will not survive.
We can find bumblebee nests, colony sites, but they're remarkably difficult to find.
So this is it. It's just a little hole into the ground, and you might see bumblebees going in and out of there. And that's, you know, could be the entrance to a colony.
Many bumblebee species nest below ground in abandoned voles nests. And of course, in many parts in the world, we don't have those anymore because we manage the land with these big machines and they sort of flatten everything down below.
And so one of the things that makes this high-quality bumblebee habitat is pretty granular, loose, easily dug soils. It's remarkably dry too, as we know, but there's a ton of naturally occurring rodent activity here. And so as we walk around and look through here, you'll see lots and lots of rodent holes. And those are primarily what a lot of these bumblebees use for their nesting sites. There we go. This would be a great bumblebee nest right here. They're not very deep. They don't have to be. It could be just a couple of centimeters below the surface. A fully grown bumblebee colony wouldn't necessarily be any bigger than a softball.
Over the last 20 years or so, we've helped install, in the neighborhood of 1 million acres of pollinator habitat and invertebrate habitat on farms throughout North America. Bees and other pollinators need food. They need shelter, and they also need a place to overwinter. And that place to overwinter is different than their nest. They actually will dig a hole underneath the ground, just a couple inches below the ground, we believe, underneath leaf litter, underneath pine needles, and that's where they spend the winter. So half of their life is sort of spent in this solitary life phase. And then they need these sites to be connected. So we need to be working not just at a homeowner scale, but we need to be working at a neighborhood, at a community, at a citywide, at a statewide scale to allow connectivity between these islands of habitat. Nesting is one of the big unknowns for bumblebees. Like, we know almost nothing about, especially at a species by species level, we know almost nothing about where they nest, what components are important, or where they overwinter. Once a species is protected under the Endangered Species Act, it regulates activities that can happen in the spaces that they live.
Whenever a federal action has the capacity to harm an endangered species, so like you might think of like road building or building a railroad or something, these like have the capacity to destroy habitat, which might harm endangered species. A species could be designated critical habitat, which protects a certain piece of its habitat from development or other harms.
And most of those impacts are where there's a federal nexus. So on a project that's being funded by the federal government or on federal lands, right, those animals are protected.
Well, certainly it's arguable that municipalities have access to more idle lands that could be put to use for bee conservation than most of us do. And these involve acres that are otherwise unoccupied. It's like the margins along a park, the margins along a fence row, power right-of-ways, which tend to be mowed. These could very easily be instead converted into bee forages, perennial flowers, clovers at the very least, that come back and reseed themselves each year and provide forage for land that's otherwise a pollinator desert. This is a good thing that municipalities can do. The roadsides, the medians in between 4-lane highways can easily be converted into forage space. Grass doesn't do pollinators any good. But if it's a blooming plant like clovers, this is one step above just grass.
My daughter and I, Allie, thought, we need this, a community garden that will give to others. We put together a business plan and what it would take and materials and budget, and then we contacted somebody in the city. He took it to the town council and the mayor. They got behind it, set aside the land. The garden reports to the tree commission within the city of Ackworth. People donate money, we put it all into the garden, and then we take all the produce and we donate it to, right now, we're supporting one subsidized senior apartment complex. We hope to have 2 next year. Mark has become our leader in plant health and happiness. He is the reason we are at 1,000+ pounds this week. His talent and his dedication to keeping this organic no-till garden alive and thriving through the heat and the drought and the watering and the non-watering, and his talents helped the garden take off at the other end.
My background is almost entirely construction, but I've always loved to garden. I've been gardening the entire time I've lived here. I gardened when I was a kid. I got, I don't know, 70 or 80 house plants. I love plants. And actually, Lori set up a plant swap, take plant, leave a plant kind of thing. And I came down there and they were signing up volunteers, and I was like, oh, this is perfect. It's half a mile from my house. And I came down here the first day when they were literally building the beds. And I guess I arrived way more prepared than everybody else did. I had a full set of tools, and you know, because I understand the plants and the construction. Now look at him, jumping right on the flower. That'll be a raspberry in 3 days.
These were just a few seeds. You can see the stumps that we had to cut there and over there. That was okra. How tall was our okra?
10, 12 feet.
Big, gorgeous, beautiful blooms, and we interspersed zinnias in it. You can see the stumps. I mean, that's a massive little okra plant. We just threw so many seeds down. I mean, we're probably on seed overload, but it created such a full, thriving, diverse pollinator section. And we get some campers here and we host little programs. What I say to the kids is the pollinator bed is the party, it's the dance. All the bees and the wasps and the butterflies and ladybugs, they come to party, and they party hard out here. And then they're looking around and they go, oh, hey, what's over there? And then they all move into the garden. So it draws this big section, kind of draws them in, and they just like pop on right through the fence.
Hidden under some of this is the native milkweeds, and then we've got marigolds and I don't even know.
Zinnias
and
Cosmo. 80% of everything here was grown by seed. Those were just 2 little seeds that plopped in the ground. I guess it must be about 10 feet tall because our fence is 8 feet tall to keep the deer out.
Yeah, we do have a problem with the deer.
So that was the biggest reason why we had to have such a high fence. And when you see this in full bloom, it is just amazing.
It is amazing. And then we plant some in with the plants as well, so there's always something blooming. Because if there's always something blooming, there's always bees. Because you want those bees there, because they're really good for tomatoes, melons, because they need something that really shakes it. And bumblebees do that, for sure. And actually, they stay out here. In the cold mornings, you can come out here, they're asleep in the flowers. They don't even leave the flowers. They stay out here overnight and wait for the sun to come up and then come back to life and start eating again. They'll sleep on the flowers. I've seen it all the time. And in the afternoons, it's hundreds and hundreds of them. They're everywhere and they're buzzing around. Clearly, the addition of the wildflowers was the key right there. The cucumbers did really well. We got 130 pounds of cucumbers from that one 8x4 bed. Because cucumbers, and every member of that family has male and female flowers, and they're individual. So if a bee doesn't come along, hit your male flower and then hit your female flower, you get no fruit. And they are covered in blooms. I mean, hundreds are open all the time. They're not open that long either. They're only open for generally 3-4 hours in the morning. So the bees getting out at first thing in the morning is crucial to getting that fruit When the squash is here, any kind of squash is here, the flowers are huge. There's a bee in every single bloom in the morning. So we don't have to worry about coming out here and doing it ourselves.
So what's this one, Jess?
Oh, wait, you're putting me on the spot
Yeah,
here?
I'll put you on the spot.
Oh man, I'm probably gonna get this wrong. Like, I guess my first guess is Melanopagus, but
Yeah, so the local morph of Melanopagus looks very much like this, but if you see on the posterior thoracic band, it's bisected with a little bit of black.
Yeah.
And this is a queen too. This is what was formerly known as Bombus bifarius. So now this would be considered Bombus vancouverensis and the subspecies Nearcticus, which is widespread through the west. She's really mad about being in there. She thinks she can get out of there, but so we're gonna let her go. She was visiting this cool little flower that's just covering this hillside. There she is, just crawling around, crawling into the vegetation to escape. Here's a good example of how the bumblebees will use multiple different plants. This bumblebee here has its pollen baskets full of lupin pollen, but it's nectaring on this other plant to get some carbohydrates. The reason for that is lupins don't have any nectar. So this bee is collecting the lupin pollen and then coming over here to drink nectar and fuel up.
It takes a lot of skill and control for this thing to fly efficiently. And so when we do find them resting, because bumblebee flight is very energetically expensive, we also find them grooming as well. It helps keep them as efficient and clean as possible. Also, a lot of these bumblebees, like we were mentioning earlier, have naturally occurring pathogen and parasite loads. And so grooming helps keep things down, like mites and other nasty things that tend to live on and hitch rides with bumblebees.
the decline of Franklin's is interesting, and I think one major issue was definitely disease spread from honeybees in the area.
They really started seeing widespread population declines and losses of entire hives, and a lot of people who were paying attention to the honeybees really started raising the alarm.
I think the first colony was thinking about swarming.
Oh, really?
Yeah.
That would be a spectacle.
Yeah.
I think they are swarming. This is a real, you need to get this. This is a rare event. Well, what we have happening here is a honeybee colony that is swarming, and swarming means colony division. It's a colony's way of splitting and forming a new one. And this colony is, they have reared a queen. This blue hive there on the end, the new queen stays at the parent nest, but the old queen flies away with about half of the worker population. And you can see that cloud of bees up in that tree. They're forming a visual focal point, and they're going to consolidate on a limb up there. And they will cluster there temporarily for about an hour or so, and then the cluster will eventually move away to a more permanent site. When I started keeping bees in the 1970s, it was standard for a queen to live 4 years. We would have marked queens. We knew her age and history that last for 4 years. Well, this never happens anymore. We're fortunate now if we get a queen to last through one season. So there's 100 different reasons for this. It's probably attached to the types of things that are making bees decline in general. You know, pesticides in the environment, viruses that are spread by parasites, and that all adds up to poor longevity for queens as well.
There are about 5 or 6 species of honeybees worldwide. All the other bee species, so the other 20,000 bee species, they don't make honey. So they just collect the nectar from the flowers and they feed it directly to their young.
And you know, honeybee, for all of the headlines that we read about them, there's probably more honeybees on planet Earth today at this moment than at any time in natural history because of managed beekeeping. I'm going to use the smoke just to kind of puff the bees and let them know that I'm arriving, and that disorients them so they're less likely to get excited. This is a comb of honey. The freshest food product in all of agriculture is honey. Honeybees are valuable pollinators because they're so manageable and the techniques are worked out and they can be cultured in the millions. And commercial scale beekeepers will have thousands of colonies in one operation. They're mechanized, they can be moved and hauled with a lot of ease and facility. So it's for this reason that honeybees are the standard pollinator, but they're by no means the most efficient on an individual basis. And because they're year-long active colony, they are adapted to visit a lot of different types of flowers. They're generalists. Whereas the solitary bees, who have a very brief life cycle, they are adapted to be very good pollinators for whatever crop or plant is blooming at the same brief window of the bee's active season. One of the flagship examples we grow here at the UGA Horticulture Farm, and that's blueberries. We have native crop of blueberries that grow here at the farm and throughout the southeast, and we have lots of native bumblebees that pollinate them very well.
Bumblebees contribute like millions of dollars to the agricultural economy every year, and they live there and provide pollination service, which is really important. Bumblebees have value much beyond how they can grow food for humans. Without bumblebees and a whole community of bees, our natural ecosystems would really become impoverished because there's so many flowering plants that depend on bees for pollination. And if they don't have that, they can't produce seed to continue to produce. Bumblebees are absolutely better pollinators for some plants compared to honeybees. That's why in a lot of greenhouse situations, the bumblebee is the preferred bee.
One of the main effects and leading sort of hypotheses for the decline in Franklin's bumblebee and the rusty patch bumblebee and the western bumblebee, these bees that have been petitioned for endangered species listing, is actually a disease. It's a fungal pathogen that we believe has been spread and amplified by the commercial bumblebee industry. If you're a farmer right now and you grow tomatoes in a greenhouse, you can buy a box of bumblebees from a lab and they'll ship it to you. And it's believed that in the mid-1990s that these colonies had a fungal pathogen that was then spread and amplified throughout North America and transmitted to our wild bumblebees and likely caused the rapid declines that we saw in these bees in the mid-1990s. And that industry is basically unregulated. We have no idea where those colonies are being shipped. We have no idea how many of them are being shipped around. Industry is not sharing this information with us. In my mind, if the federal government takes an interest in pollination services, which they should, it's $1 billion industry and it's feeding the people who live here, they should be interested in pollinator conservation and regulating that industry, at least understanding where those are being shipped so that we can potentially track disease outbreaks if they happen again in the future. And then also establishing like a clean stock program so that those animals are actually tested independently before they leave the laboratory so that a farmer can be sure that the colony that they're putting on their farm that's going to interact with their wild bees isn't spreading diseases to them. They should know that. And right now, we don't. There's no independent clean stock program out there that's protecting native bees from these commercial bees.
Many people bring their honeybees out to public lands, just like grazing cattle. It's a similar process for honeybees. Unfortunately, bringing in honeybees, which are in effect livestock, to an area where there weren't honeybees before, they can outcompete the wild bees in the area because there's just so many of them. A honeybee hive can be millions of bees across multiple colonies. In addition, the honeybees can bring in diseases with them, which can be spread to wild bees.
For the extent of the decline that we've seen for these bumblebees that are at risk of extinction, the only real thing that explains it is probably an introduced disease that they were not evolved with, because it happened so rapidly over such a large landscape. It's still a little bit of a guessing game, but in terms of the amount of area where they've declined from, something like COVID for bees makes the most sense. And this has happened in so many other animals, like Serengeti lions and mad cow and bird flu. It happens actually all the time, where we see novel diseases being brought in and it just wipes out wildlife. So this is probably the leading hypothesis for these species. They're being introduced from the use of managed bees, so managed bumblebees in greenhouses and managed honeybees. Honeybees are bringing in a whole bunch of viruses from Asia and Europe, for example, that our native bees have not co-evolved with.
Taking that agricultural problem and bringing it to our wildlands, our wilderness areas, our national parks, our state lands that are refuges for these animals in some of the last places that haven't been impacted by, pesticides and disease and agriculture is not the right solution. Leave our natural wild areas for our wild bees. We can't be bringing honeybees there and bringing diseases and competing with our native bees in our public lands. That's just, for me, for the most part, a pretty clear no-no.
You will find in garden centers oftentimes bee houses, which are little blocks of wood that have had holes drilled in them to invite tunnel nesting bees to nest in them. This is good, but you have to also be aware that the parasites and diseases can accumulate in those tunnels as well. So sometimes they may work for a season or two, but then be a death trap in later generations.
So bee condos, once people started caring about honeybees or bee declines, they popped up at Costco, right? They became so mainstream, oh, you can just put this out and you'll save the bees. But a researcher here in Toronto studied bee condos for 3 years, and what he found was that they tend to be non-native bees mostly that are using them, and that they are the native bees that are in them are more highly parasitized. So when you think about it, you're basically making a buffet of bees. The bees are in a more highly dense situation than they would be in nature if they were just kind of nesting in their own twigs. There's a lot that needs to be figured out in terms of cleaning them out and fungus growing inside those things and parasites thriving in them. So I would just be super cautious about any kind of human-made solution that is not really scientifically supported.
There's this broad education out there. I think that people have learned the save the bee message, and they immediately start thinking about honeybees, and the backyard honeybee industry has taken off. And all of these things probably are not good, ultimately, right? Keeping honeybees in your backyard is not a good thing to do. It's not conservation, right? That would be like me saying, oh, look at these chickens I have in my backyard. This is bird conservation, right? That is not what you do when you have chickens in your backyard. You say, look, these are beautiful animals. I learn from them. I get eggs from them. And that's great. That's why I'm doing this. I'm not practicing bird conservation. It's the same thing with honeybees in your backyard. You get honey, you can have wax. They're beautiful animals. You can learn from them and enjoy them and educate, your neighbors about them. But it's not conservation. There's no conservation that's happening. In fact, they're probably competing with the native bees that used to live in your backyard, and stealing pollen from them.
The reality is, anytime we manage any animal, whether it's salmon or cow or chickens or pigs, there's always high levels of diseases. As a species, human species, we have not figured out how to put a whole bunch of animals together and breed them at high densities, much higher than are found in nature, and not have disease outbreaks happen. So if you look at honeybee hives in the US, for example, it's over 95% that they will have varroa mite or some other virus or something. So beekeepers really just try to treat their honeybee hives, keep those disease levels low, but it doesn't stop the diseases from being spilled over into the wild, because honeybees are not like chickens, they're not inside a coop. But the solution that the public and policymakers have come up with has been more honeybee hives in cities, for example. Like how many sustainable initiatives for businesses are throwing a honeybee hive up on a rooftop, right? So it actually made the #1 threat a lot worse, and it's frustrating because these people are actually thinking that they're helping.
The research that we've done and that others have done show that in many different crop systems, that if there's enough habitat on a farm, that there will be enough native bees to provide 100% of the pollination services.
Pollination is a strategic input in modern food production, in part because it increases yield. Think about it, so much of what we do in agriculture is oriented at conserving losses. You know, we are worried about a pest, so we spray to keep a pest pressure down so that we don't lose more of a yield. But pollination is one of those inputs that actually raises yield. The more pollination you get, the more yield you get.
Oh, I think I got a good one. Black face, but yeah, it's just like its abdomen is almost entirely black, but just like the little white patch.
If you're gardening for pollinators, you can put a sunflower in your garden to get sunflower bees to come to your garden. Yeah, exactly like that.
I haven't looked at enough of the Franklin specimens to really have a good sense of what they look like. I just look for the black abdomen.
If we just get right over here, the ground is just nothing but flowers.
Exactly what I'm pretty black.
Yeah, I mean, yeah, that's as black as they get, really.
That's really black.
Oh no, yeah, we gotta show this one to Link too.
Hey, Link.
Link,
Oh, cool.
come here.
Uh-oh.
Oh, we got another good
Just
one here.
Tyler did it again.
Apparently so.
And so there you go. That's a worker Western bumblebee.
Yeah, they've become very rare out here. We only find just 1 or 2 a year.
You can see the yellow shoulders, and then Western bumblebees in this region have a novel color form. So they don't have a long white tail. The ones in this area have the apical segments, just T5 and 6 with the hairs off-white. So it's a little hard to tell, but the face is very round.
Round face, yeah,
So
I haven't looked at them closely.
And the
enough
round
to
face
see.
is a consequence of having a short cheek. And so, like Franklin's, Bombus occidentalis, Western bumblebee, has a short cheek and relatively short tongue. So if this was a Franklin's, it would be the exact same, except that yellow would extend further between the wing bases, whereas between the wing bases on this specimen, it's just black. So this is a worker, so it means there's already an established nest and that the queen was successfully mated. And so I'm sure she's building up her workforce right now. We don't know how big her colony is because we don't know where it is, but this is the first Western bumblebee that we found, thanks to Jess. We've seen hundreds and hundreds of bumblebees. We've seen 1 occidentalis so far, so good thing we have Jess with us. So Kyle caught another species. This is a Bombus appositus, a white-shouldered bumblebee. Really kind of nice looking with white shoulders and a more yellow, tawny body. You know, the Western bumblebee we just saw was a worker, and so is this one, but you can see the size difference, that this bee is probably twice as big as the one we were just looking at. Real beauty. This bee is in the subgenus Subterraneobombus, and so there are concerns worldwide for members of that subgenus that they're in decline, especially in Europe. So we got, how many do we have so far? We got Vaz, Insularis, Occidentalis, Appositus, Mixtus, any others? Yeah, 6 species. And so if we can detect 6 just by swinging nets, there's probably 9 or 10 present. Some of the other ones are just more difficult to find.
Yeah, as we're having this interview, we've noticed across the street there's some landscapers spraying pesticide and mowing the neighbor's yard. And as someone who really appreciates wildflowers and bees, I can just see that their lawn could have so much potential for pollinators. Currently, it's a patch of green grass, which really does nothing for wildlife.
You're right when you say that we shouldn't be planting grass. Native green grass provides basically no habitat for native animals of any sort, and in fact may contribute to the invitation of non-native species like ants and other animals into your home. So planting native plants is the best thing that you can possibly do, and even being a little bit messy with those native plants. So we like our gardens to look really neat and tidy, and I think sometimes it's okay to be a little messy. And that doesn't have to be in your front yard or in your showy garden, but in your backyard, create a space that doesn't look different from where I'm sitting right now. Don't mow it for a couple of months. There's no reason necessarily that you need to, and that's gonna just create biodiversity. And all of that biodiversity is gonna create benefits, which ultimately will also reduce the need for using insecticides. The ecosystem works if we create all the different parts for it. It's had millions of years to figure that out.
There are tons of alternatives out there that use less pesticides and rely more on natural enemies. I'm hopeful that we can continue moving in that direction. For decades, since the EPA's inception, EPA has never consulted with Fish and Wildlife when it comes to registering pesticides. But things are changing thanks to pressure to force EPA to consult with Fish and Wildlife to factor in endangered species when they think about what pesticides should be allowed to be used and what ones shouldn't be.
Right now, the majority of testing that happens for these insecticides for approval to be used in the United States on farms and backyards, all of that testing happens on European honeybees. But European honeybees have a vastly different life cycle, a vastly different life history, and a vastly different physiologies than our native bees. And so just testing, European honeybees and using that as a proxy for our 3,600 species of native bees doesn't work.
And because bumblebees, unlike honeybees, go through a complete life cycle every year, their success depends upon the survival of the next generation of queens that begin diapause or hibernation late in the fall, stay underground over the winter, and then emerge in the spring to start new colonies. And so that's a different reproductive strategy than honeybees.
Pesticides are a huge issue for bumblebees and the thousands of native bees.
We need to actually find out the effects of these chemicals on our native bees before we approve them for broad use across the United States. And I think the other thing we really need to keep in mind there is that our native bees, because they live in the ground, they have different routes of exposure for these chemicals, right? So anything applied on the ground doesn't only affect their flowers, it also affects their nests. And that's not tested in honeybees, right? We're not spraying their nests with insecticides and seeing how that impacts them. So I think just putting some small changes like that could make a huge difference for understanding how these chemicals affect bees and what maybe small or large things that applicators could do to protect bees.
We've been working to force the EPA to consider endangered species specifically when they register pesticides. If we can protect endangered species threatened with extinction from pesticides, that's going to benefit all kinds of other species, as well as human health and water quality.
We've been looking specifically at how many pesticides are found on farms and in wildflowers and in nurseries, and there's some concerning results that we found in the level of pesticides that are being found in plants, both horticultural and nursery plants as well as farm plants.
The science tells us that there are some pesticides where the harms are really just too great to wildlife.
I think it's important to recognize that We've been talking about neonicotinoids for a while. Like, that's the class of insecticides that we're worried about, that a lot of people are talking about. They're nicotine-based, they're a neurotoxin, so they're highly, highly toxic for almost any animal that ingests them.
Almost all neonic use in Europe, for example, is restricted.
You know, in response to some of this negative information about neonicotinoids, these companies are now producing different chemicals that are still systemic, still have the same mode of action, but have different active ingredients. So, you know, we like to, instead of just using the term neonicotinoids, we're trying to just use the word, you know, systemic insecticides at this point.
Systemic means that if it's in the soil, a plant will take up the pesticide and it will travel throughout the tissue of the plant. So it will be in its leaves and it'll be in its pollen and nectar.
These are, you know, basically the most broadly used insecticides on the market. They're what would probably be recommended if any homeowner, you know, went somewhere to find something, and they're obviously heavily marketed by pesticide companies to farmers as well. One of the main issues with these chemicals, because they're water soluble, they're actually absorbed by the plant tissues and expressed in every cell in the plant. So every time a bee drinks nectar or eats pollen, which is their only source of food, if that plant has been treated with that insecticide, they are getting a microdose of that insecticide for the entire life of the plant.
Their nectar and pollen is contaminated, and that nectar and pollen is then brought back to the bee's nest.
And in fact, in some woody plants, it's been shown that those chemicals can still be active even up to 7 years after a single application. It's complicated. There are a lot of factors involved, including, you know, obviously an industry that makes money from selling these products, you know, that have a heavy lobby and have a lot of influence, probably a lot more influence than you and I would like to actually admit.
The EPA often says that they look at the best available science, but the truth really is that they often ignore independent, even peer-reviewed literature studies that look at the impacts to pesticides. They almost entirely rely on studies that come from the companies that are the one to register these pesticides. So you can see that there's a conflict of interest. In reality, EPA is a captured agency, especially the pesticide office. The companies that want to get a pesticide approved pay a fee to get a pesticide registered.
If you're a farmer and you have an economic threshold for your livelihood, that's a separate conversation that I'm willing to have. Maybe still we shouldn't be using them prophylactically. You know, we should have some threshold at which we say, okay, there's a danger here, we should apply them.
Farmers generally want to help bees, and if they actually know that they don't need to use pesticides and can be assured that they can still make a living managing their lands in different ways, then they probably would be allies and for bee conservationists.
Pesticides like dicamba, which is a really popular herbicide, it's incredibly volatile, so when it's applied on one piece of land, it can just blow over to a neighboring farm and it can harm the crops there. But more than that, it has the ability to just like blow into a more natural environment and then poison wild vegetation and wildlife that relies on these little bits of habitat.
But right now, farmers they're on seeds and they're treated before the plants are even in the ground. Before there's a pest to treat, you know, the plants have already been treated. And it's really having profound impacts on invertebrate communities throughout the world. Next to a farm field that's been pre-treated with these insecticides, the weeds that are growing there that once provided, you know, important food for bumblebees and other pollinators is now, you know, laced with these toxic chemicals because of how easily they move through the environment.
I think that's kind of an elephant in the room, the fact that we are so reliant on artificial systems to produce food, whether that's through irrigated water, herbicides, fungicides, insecticides. We need to look at more sustainable ways to get their benefits without the toxic collateral effects.
We've made some steps, but largely you can buy these over the counter at most home improvement stores and apply them without a license, and it's dangerous. It's really, honestly, quite dangerous.
Rachel Carson's Silent Spring, one of the books that started the environmental movement, celebrated its 60th birthday this year. If you could bring Rachel Carson back from the dead and ask her how we're doing right now, she would be disgusted. We have made strides to get rid of some of the worst ones, but we still have a long way to go.
And there's been a very promising study out of Canada using canola growers. And these scientists were able to show in this particular system that farmers could take certain numbers of their canola acreage out of production, convert that acreage into pollinator habitat, and in the end of the season, the grower would still gain more profit than in the conventional system of putting it all in production. That's remarkable. Think about that if you're a farmer. Wait a minute, you're asking me to take some of my acres out of production just for the bees? Well, yes. We think this would work under these conditions. Think about that as a win-win. The farmers are saving the bees, protecting the environment, and making more money. That's what I call a win-win.
Several species, like the rusty-patched and the American bumblebee, their declines have been really steep in only the last several decades. They don't rely on native prairie, so they're actually really adaptable. Trying to pull apart this puzzle about why they're declining, it's not just habitat, it's not just an invasive species, it's really this combination of factors. I think it's no coincidence that the decline of the bumblebees, that's also at the same point that the use of neonic pesticides has really gone up. Neonics started being used in the 1990s, and then they really ramped up production after 2000. So this widespread adoption of this insecticide that is really toxic, it has all kinds of effects. It impairs their immune systems, it alters their the microbiome that they have, it modifies their behavior, all these things are known. Then you add the introduction of honeybees, which are unfortunately able to spread disease. So unfortunately, it's really this combination.
We have to have a fundamental reckoning of the way we use toxins. At the end of the day, we are still unloosing into a habitat with far less than complete knowledge of its outcome, acute toxins that do have non-target effects. And none of us likes this situation, but we do need to be aware that these consequences are accumulating. And we just have to ask ourselves, what kind of a world are we going to pass on to our children, our grandchildren? Do we like that picture? Or would we like to maybe start changing it now? When we start talking about systemic solutions to these problems, none of them, of course, are easy, are they? We're talking about changing a system, changing the way we produce food. And that's not going to happen overnight. It's not going to happen easily. But the kinds of systemic changes that need to happen are making our habitats less hostile to pollinators and other beneficial organisms, to at the very least be mindful of their life history needs for nesting sites and for forage, and to give it to them, whether through private practices of leaving fence rows unmown or government agency level through land set aside or incentivization programs to incentivize farmers to make their lands friendly for pollinators.
If we can all work together on this, I'm hopeful that we can help them and a lot of species can make a comeback. We're holding out hope that we're going to find Franklin's. It's definitely could be out here. And I think that's what brings all these people together to come look for this species. We know it needs help, and if we find it, then that means it can get the help that it needs to potentially recover. Until we find it, it's potentially extinct, and that's just it's unfortunate. But unfortunately, we never studied it well enough before to. We don't know as much about its biology or its populations as we could have. I think moving forward, there are a collection of insects specifically that are waiting to be listed under the Act. So that's like the monarch butterfly, the western bumblebee, the American bumblebee, and then a few others. These, I think, are really special species that have seen broad declines across their huge range. Like the monarch butterfly travels from Mexico all the way to Maine and into Canada every year. And so it touches like every single state. And it's the same with the American bumblebee, previously found in 47 of the lower 48 states. So having one of these species protected under the Act would have huge benefits to all kinds of species along the way. Just such a great habitat up here. We've already found about half a dozen species already, and there's potentially several more that we haven't found yet. Yeah, Franklin's bumblebee will probably be the first species to have gone extinct in North America. Franklin's was really unique, but yeah, it doesn't mean that we can't do something positive for the other 45 bumblebees in North America. And I think through raising awareness, through regulation, and through the intentional habitat restoration, I think we can have a lot of positive impacts. It'll take a lot of effort and time, but we're working on it.
So let's keep looking and see if we find a queen. It's congested. Now that's mature brood. See that cardboard colored stuff in the middle? That is...
it's ready to get the hot honey out.
It is. Well, it's brood. These are baby bees.
Oh, okay.
So I'm going to show you a baby bee. You can kind of tell by their appearance. See this one right here? She's kind of whitish. There she is. I'm gonna stop her, pick her up. See how she's white?
Oh, yeah.
Her hair is still matted.
She does look like a baby.